Hello, this is Richard Walker from Lucidate. Welcome to the third video in this series on Ethereum. In the first two videos, we discussed the basics of Ethereum, highlighted the similarities and differences between Ethereum and Bitcoin. We discussed smart contracts and introduced Solidity, a high-level programming language to develop smart contracts. In this video, we're going to build our own cryptocurrency and mint coins. The code to mint, burn, transfer, check balances, and all other interactions with our newly developed cryptocurrency will all be written in a smart contract. We'll start with a discussion of why one would want to build a new cryptocurrency. We'll discuss the ERC20 standard. ERC stands for Ethereum Request for Comment. ERC20 sets out the standards for currency tokens. By adopting a set of standards, your currency can interoperate with other smart contracts on the Ethereum blockchain, built to handle tokens and currencies. Standards are kinda useful. We'll then review Lucidate's implementation of an ERC20 token, the Lucy. Finally, we'll look at the smart contracts deployed to an Ethereum network using Etherscan, and we'll review the mantra, the code is the contract, in terms of the token smart contract that we have just deployed. So first, let's discuss why one would want to create yet another cryptocurrency. Surely we have enough already. Why create a cryptocurrency? Well, you might want to raise money. Many firms have raised funds for an Ethereum project by minting and selling tokens. An initial coin offering is a way to raise funds and allow investors to participate in the upside of your enterprise. Ethereum itself raised funds in 2014 using an ICO of Ether. A governance token. Like any other enterprise, blockchain projects face choices, changes to standards, fees, user interfaces, prioritizing one piece of functionality over another. Governance tokens represent voting power on a project. Uniswap, Aave, Maker, and SushiSwap are examples of governance tokens. An in-game currency. Gaming tokens can reward players for achievements or for playing time. These tokens can be exchanged for in-game assets. As such, they have value for other gamers and can be traded on exchanges for ETH or other currencies. Examples of gaming tokens include ApeCoin and Decentraland. Oracle access. Oracles are pieces of software that connect blockchains to external systems, allowing smart contracts to execute based on inputs originating from outside of the blockchain. Tokens serve as currency to pay network operators for retrieving and preparing off-chain data and performing computations. Chainlink's Link is an example of such a token. This is also Lucidate's primary motivation for launching the Lucy token that we will explore later in this video. Industrial uses, for instance, a central bank digital currency. These offer central banks the ability to increase the efficiency of payments, improve resiliency of payment systems, increase financial inclusion, and provide targeted monetary policy. Many central banks are exploring this concept, both on public, decentralized ledgers, as well as on private, permissioned ones. Education. Finally, launching your own cryptocurrency is a valuable exercise in itself. It's a great introduction to distributed ledger technology and Web3. As a project, it introduces a whole host of concepts and has an evident, obvious, and satisfactory success criteria, that of securing your own freshly minted coins in your wallet. It should be noted that due to the popularity of the Ethereum blockchain, which has increased gas costs, and the rise in the value of Ether, Ethereum's currency, that the cost to deploy an ERC20 token in 2022 is somewhere between $5,000 and $15,000. Gas costs can vary significantly throughout the day based on supply and demand. Here's a chart and a heat map of the Ethereum gas costs for the past week in 2022. All times are in British summertime. While tens of thousands of dollars clearly won't deter business ventures, it might put off some people developing tokens for educational purposes. It shouldn't. You can deploy a token to one of many Ethereum testnets like Kovan, Rinkeby, or Ropsten. This can be done for free, and we'll look at that later in this video. The ERC20 standard. Let's take a closer look at the contract specification to get some familiarity with how these coins are implemented. Let's first ask ourselves what properties and functions should a cryptocurrency have. These are set out in the ERC standard that can be found at the URL on your screen. Clearly, developers are free to add their own functionality in addition to this should they wish, but this specifies the minimum set of functionality that must be implemented. So an ERC20 token must have a name and a symbol. Our example token will be called the Lucy with a symbol LUCI. It will also need a decimals value. This is the number of decimal places that the smallest denomination of our currency will have. As an example, British pounds and US dollars have a decimal value of 2. The smallest denomination of the dollar is the cent. The smallest denomination of the pound is the penny. A single penny and a single cent are represented using 2 decimal places. By convention, tokens on the Ethereum blockchain have a decimals value of 18, giving very small fractional denominations. The contract must also hold the total supply. That's the amount of all minted coins of this type in circulation. The very heart of the ERC20 contract is the balances mapping. This is simply a mapping or a lookup table of the addresses and the corresponding amount of this currency owned by that address. Thus, the smart contract itself keeps a record of all of the owners of this currency and how much of the total supply each owner has. A token supporting the ERC20 standard needs to provide view methods to be able to access these variables. As these view functions don't alter the state of the blockchain, they can be run on a single node rather than have every node perform full validation. This means they consume no gas. These view functions allow callers to get the name, symbol, decimals, and total supply. There's also a balance of function that has an input, an account address. The balance of function uses this input address to look up the amount of tokens owned in the balances mapping. There are 2 workflows to support the transfer of tokens. The first is simple and requires a single function called transfer. The spender calls this function and specifies 2 inputs, the amount to be transferred along with the receiver's address. Within this function, the balances mapping will need to be updated, decreasing the spender's balance and increasing the balance of the receiver. So in order to transfer funds using this method, there's no need for the spender to specify their address. Why is this? Pause the video for a minute and think why this is the case. The reason we don't need the spender's address is that this is one of the things available to us through the built-in objects that we discussed in the prior video. The message built-in object contains the address of the message sender, which for this function is the spender of the coin. The second transfer workflow is to allow third-party smart contract addresses to transfer funds on behalf of another account. A typical use case here is a third-party contract such as an exchange or a derivative smart contract transferring funds. To prevent unauthorized transfers, there are some additional steps required. Firstly, the ERC20 requires an additional mapping called allowed. This mapping contains two addresses, an owner's address linked to a spender's address. This pair of addresses maps to an amount that's allowed to be spent. So at first this might seem a little confusing. Why do we need this mapping of an owner and a spender to an approved amount? A useful analogy here is credit card limits. Let's say Lucy has two credit cards, a Visa and a MasterCard. Visa and MasterCard both allow Lucy Day to spend their money with merchants as long as she pays it back. Each card has a limit, and each limit can be different. If Lucy has a limit of $5,000 on Visa and $10,000 on MasterCard, then the allowed mapping for this use case would look as it is on your screen. The allowed mapping in the ERC20 contract does exactly the same thing. It allows a third-party contract to transfer funds, but only up to an agreed limit. The ERC20 standard contract requires an approve function to update this mapping. This allows a token owner to approve a third-party spender to spend up to a permitted value on their behalf. Again, think of this like MasterCard setting, raising or lowering a credit card limit. This allowed mapping can be viewed with an allowance function. This will return the limit that a spender has left on a particular owner's account. With all of this set up, the transfer from function can then take care of the third-party transfer of tokens. As with the first workflow, it needs to update the balances mapping. It will do this once it's checked that a valid allowance exists for this third-party transfer. Again, think of this allowance as analogous to a credit card limit. Finally, there are two events that need to be created. These are transfer, and this event must be triggered when tokens are transferred. The event will emit the address of the payor, the address of the payee, and the amount transferred. Approval. This event must be triggered on any approval event. It will emit the address of the approver, the approved, and the amount approved to be spent. In Solidity, emitting an event will inform everybody on the blockchain of that event. Implementing all of these functions and events and conforming to the standards means that your token will be usable by other infrastructure on the Ethereum blockchain. Wallets like MetaMask will be able to handle your currency, and exchanges like Kraken will be able to deal in your token once approved. So this is a lot to take in at once. Please feel free to rewind and review to get comfortable with the details of the token standard. To do our own review and reprise the standard, let's take a look at Lucidate's implementation of the ERC20 token. We can see that the code required to create a bare bones ERC20 smart contract is neither lengthy nor overly complex. We can see in this contract definition the variables declared in the contract for the symbol, name, decimals, and total supply, as well as the mappings for the balances and contract approval. The constructor, which is a special function that's called once and only once when the contract is deployed to the blockchain, initializes all of these variables, the name, the symbol, the decimals, and supply, to their starting values. It also emits a transfer indicating that the account that has deployed the contract currently owns all of the minted tokens. Public methods are automatically created for all of the variables declared in the contract. We also set a contract owner variable. This is set to the address of the account that created the contract. Then we see an only owner modifier, similar to that was described in the previous video. When a function is decorated with this modifier, it can only be executed by the owner account. We'll see this later in the mint function. Here you can see the balance of and allowance functions. Pretty straightforward lookup table type stuff. These simply output the results of the lookup tables corresponding to the input arguments passed into these functions. Now, there's some common logic shared by both of the transfer workflows, the transfer and the transfer from functions. This is the logic to update the balances mapping. So while it's not necessary, it's usually good practice to put that logic in a helper function. This means that the transfer and transfer from functions can both call the helper function when invoked. The simple transfer workflow can use the helper as is. As we discussed earlier, it makes use of one of our good friends from the last video. The built-in message object lets us get the address of the sender. So this function only needs to take in the recipient and the amount as input arguments. The slightly more complex transfer from function first needs to make the allowance and approval checks prior to calling this helper function. Here we can see that the transfer from function makes these checks using another good friend from the last video, the require function. It updates the allowance table to reduce the available limit by the amount about to be spent. And then, as with the simpler transfer workflow, it makes use of the helper function. Finally, we want to be able to mint coins. This function, which can only be called by the contract owner, creates an amount of coins specified by an input argument. It increases the total supply and places the freshly minted coins in the owner's account. Now that's it. Clearly, there's nothing stopping you from adding additional functionality required by your token. Perhaps your token will provide discounts when used to buy certain goods or discounts at a certain type of year. Perhaps there'll be a time limit triggered by a balance increase, after which the balance increase will be burned, encouraging spending rather than hodling. Whether additional features to your currency are desirable is clearly a point of discussion and debate, but they are evidently possible. Anything you could conceivably write in Solidity could be included in your token. The code is the contract. So, by way of a review of distributed ledger technology, let's go right back to basics and briefly walk through the steps to deploy this Lucy smart contract. The code for this contract was written and tested. When deployed, it was digitally signed. This followed exactly the same process we presented in our Bitcoin videos. The Solidity code was put through a hashing function to generate its digest. This digest was encrypted with one of Lucidate's private keys to form a digital signature. The contract and the signature were submitted to the blockchain where they were verified. Once verified, this smart contract has a unique address on the Ethereum blockchain. When a company or an individual wants to spend or receive this new cryptocurrency, they will invoke the functions of this contract on the ledger. On the Bitcoin network, the Bitcoin cryptocurrency is the star of the show. On the Ethereum blockchain, we can have, and indeed do have, multiple currencies. A currency is just another type of smart contract. So let's finish by looking at Lucidate's currency, the Lucy, on the Ethereum distributed ledger. We'll look at its contract address and invoke some of its methods using a block explorer called Etherscan. The contract address of the Lucy on the Rinkeby test network is shown on your screen, and it's in the description for this video. We're using the Etherscan block explorer. Here we can see the code for this smart contract. This code is what will execute when the functions are called. It's been deployed by Lucidate, it's been hashed. That hash has been encrypted with Lucidate's private key to form a signature. All this has been validated by a mining or staking node. This is the code that will run. It's immutable and unalterable. You can take this code from the Block Explorer and run it in your own development environment, or you can run it on this testnet to see how it will perform under all the scenarios you can conceive. This is a huge benefit of blockchain. It's transparent, it's provable, it's verifiable. You don't have to trust that the code does what it claims. You can test it all for yourself. Now, this is a relatively simple contract representing a token, but it could be more complex, way more complex. It might be a derivatives contract or a contract representing a complex rules-based organization, such as an exchange or a clearinghouse. But the same proof-based approach applies. You can see the contract, you can use it, you can test it, you can see if it breaks or has bugs in it. In this video, we've looked at why you might want to build your own token or cryptocurrency. We've taken a close look at the ERC20 standard in Ethereum that sets out the minimum requirements for parameters, functions, and events that a currency needs to possess. By implementing this standard, you can ensure interoperability with a whole host of other Ethereum infrastructure that has been built to transfer crypto. Finally, we built a coin and deployed it to a blockchain. Using a block explorer, we were able to see the implementation of and interact with our ERC20 contract. The code is the contract, and the contract is the code. Join me in the next video where we will take a closer look at non-fungible tokens.